what I would like to do, I hope to get to exceptions today for sure. At least the motivation part. It's quite a tricky topic, but it's kind of important to do error handling. What you learned before in 1022 for error handling, it's acceptable, but it's not very systematic. It does have some major drawbacks, which I would like to at least tell you what they are. But we'll get there. But now, what I would like to do is I would like to continue with the example we haven't finished. I'll mention that quickly. And then one more example I would like to go over. And that will complete the review part for this course. And after this, I will assume anything you really find trouble with classes and objects, review yourself and talk to me if you got trouble. Okay? Okay, so let's continue with this example here. Let's remind us what we said about object alias, especially this example here. Remember we got Alan, Mark, Tom, and Jim. So that's what we left from last time, right? And then let me just show you what we have got so far, okay? And then we'll start from there, okay? What we got from last time, we created two array of persons over here, persons 1, persons 2, and I explained these to line number 5 and 6 in detail, okay? I wouldn't bother you with that anymore. So basically, that's what we have got so far, okay? So what I would like to show you is, if you have, guys, please, okay? Okay, so now let's see how we can analyze how to trace these lines over here. I would say 7 and 8, these are the most critical two lines for the program. Once you know how the pointers or the addresses can be copied around to the right location and how you draw the arrows in the diagram accordingly. Once you can get it right, nothing's difficult, okay? So let's see how we can do that. So what I did was I copy over here. Oh, you know what? Let me finish the copying. Could you please stare at line number 8 for just another 30 seconds? I'll just complete that on my iPad, and then we'll go over it. We'll go over that together to see exactly what line number 8 is going to do. And think to yourself, how many times is line number 8 going to be executed, first of all? And each time, how is the assignment that's going to be performed going to be different? Okay, let me just make sure I copy that correctly, and then we can move to my iPad. Okay? Okay, everybody clear about what the problem is? Okay, we already have gone through up to here. I'm going to analyze to you how you should really do similar problem for 7 and 8. Okay? Basically, we're going to trace the loop. So it might be a nice review on the loop. Okay? Not really nested loop, but it's complicated enough. So let's move to iPad over here. Okay. Let's see how this might work. If you need more explanation, let me know. First of all, whenever you see something complicated, break it down into pieces that's more manageable. So I would like you to, first of all, we know that loop counter is I. I is equal to 0. Okay? And then you can see that we have some condition over here. As soon as it becomes false, we're going to exit from the loop. And then every time, the way we make a progress on the loop is by incrementing the value for I so that the condition eventually, over here, hopefully is going to evaluate to false. Otherwise, if it always stay true, what do we get? Infinite loop. That's definitely something you want to avoid. Okay? So now, let me trace it this way to see how that works for you. So what I would like to do is, I would like to draw a table over here. So the value for I, let me use a different color here. So that's something you should keep aside. Let's say the value of I, it definitely starts with 0, okay? And then let's see what the person's length is. If you go back there in the previous diagram, person's length would be 1, 2, 3, right? It's going to be 3. So I'll put 3 here. So that means I is going to be 0, and then until I less than 3 becomes false, we're going to exit from the loop. So now the question is, inside the loop, what are the values we're going to use for I? How many values are we going to use? How many different values are we going to use for I inside the body of the loop? How many? Huh? 3? Okay, 0, 1, and 2. And as soon as I becomes 3, which is the fourth value, we wouldn't use it anymore because when you go back to the beginning of the loop, 3 less than 3 will be false. We never use it. Okay? That's a very quick review on what it means for the for loop. Okay, it's going to be 0, 1, and 2. So these are the only 3 values we're going to use. Okay, and we already handled this expression over here, I. Okay, so what about, before I do the second one, can we also make a note for us? Because person's one.length never changes, that's also 3. Okay? And the second expression we got over here, let me highlight that for you. And it's not too bad. Let me use a different color here. It's I plus 1 modulo person's one.length. Okay? So let's write it down on the table and see how we can trace it. So it's going to be I plus 1 modulo 3. Okay? We know that's 3 already. Okay? So now, that should be quite easy, right? By the way, modulo, can I just test your knowledge very quickly? If I have 4, let me pick a bigger number, 187 divided by 3 versus 187 modulo 3. I don't think you need a calculator, right? I don't think. The first one? 62, right? 62, agree? Okay, very good. Hopefully you agree. And what about here? 1. And let me bother you with one more equation I'd like to show, and I will generalize it. So basically, you can say the following. 187 divided by 3, because both are integers, so that's like the quotients. I'll say put Q here. Multiplied by 3 plus 187 modulo 3, and that will give you the remainder. What should you get? 187. And nothing magical here. Let me generalize it for you. So let's say we got in general A and B being integers. Let's say X and Y. Given that X and Y are integers, so you can say X divided by Y, integer division, which will give you the quotients, multiplied by Y plus X modulo Y, you will get Y X. Okay, that's a mathematical equation here. That should always hold, given that X and Y are integers. And given that the division you talk about here is the programming division we talk about in Java. When both sides are integers, you only get the quotients. Okay? Any question about this? Quick review on modulo versus divide. Of course, again, how would you, let's say here, you can see here, let me just highlight this part here. 187 divided by 3. Of course, it doesn't divide completely. Now I only get 62. But what about I want to get more precision? I want to get something like a 62.33333. No, there are different ways I can do it, right? Okay? At least several ways I'll suggest very quickly. But you can definitely refer to the elementary programming lecture slides. Okay, I got more complete story there, but I'll mention quickly. You can say, for example, you can either say 187 divided by 3.0. That's the easiest one. Just add a 0.0, which means when either side becomes a double or has a floating point, the overall is not going to be quotient anymore. Okay, that's one way to do it. But in general, you may not have the specific values available to you. You might just get X and Y. Then how would you do it? You got to do some cast. So I'll just give you one example here. Let's say you got X and Y. You can say X divided by, you can cast one of them, for example, Y into a double. Right? That's another way to do it. Okay? You can refer to the complete story in the background slides. Okay, just want to mention quickly. Okay, so now we know pretty well how modulo works. Can we just finish our trace over here? Okay, so now let's see over here. When I is equal to 0, what's I plus 1 modulo 3? For parentheses here. 1 modulo 3, which is 1. Okay, I'm going a little bit too fast here. How about 1 plus 1 modulo 3? 2. And 2 plus 1 modulo 3, 0. You can see somehow, I can tell you that in general, if somehow you want your indices to go circularly, which means when it reaches the end, you want it to wrap back to the beginning, modulo is your friend. Okay, this one shows you why. Otherwise, let's say this, you can easily see what's going to happen. Let's go back to the original program here. I'm going to change one thing here, and let's just talk about it quickly. You can try as well. What if I simply say I plus 1 without the modulo? It's going to crash? Can you be a little bit more specific? What kind of crash?
Index out of bound.
Index out of bound exception. Which iteration? The last one. Because the last one there, let's be precise, because in the last iteration there, if we go back to the tracing table here, the last one, I is actually equal to 2. 2 plus 1 without modulo will be 3. And 3 is not a valid index for an array of size 2, right? So you're going to get index out of bound. So be careful. In the future exam or test, be careful to see if there's a modulo. So you got to follow faithfully what's written to you. Don't assume it's always going to wrap it around for you. Okay? Okay, that's good. Okay, so now, what can we conclude from here? So we got I versus I plus 1 modulo 3. And now we can see that, so these numbers are used for indices for the array. We know they are valid, but how does it work? Okay, let's try. And then at the same time, we'll try to change the arrows around over here. That's what we'll do. That's okay. Okay, so now let's see. Let's try one first. So what I would do is, let me use maybe orange here. So now for the very first iteration, we're going to say persons 0 is assigned to persons 1, 1. Okay? Agree? Okay? So how do we do that? Persons 0 is here. Is assigned to persons 1, 1, which is referring to this address over here, right? So copy this address over here to over here. That means, conceptually, this slot here is going to point to wherever this is pointing to, like that, right? Because you can see this slot is pointing to here, right? And then we got to change the pointer to point to here. So it's not pointing to null anymore. That's the first iteration. Follow? Okay, let's complete the rest. Any question, you should raise it now. Okay? Okay, let's go back there. So what about the second one? Second one, I'm going to say persons 2 at position 1 is assigned to persons 1 at position 2. Okay, let's try that. Persons 2 at position 1 is over here. And persons 1 at position 2 is over here. So that means, let me use a different color here. How about green? So that means it's, this slot here is just going to point to over here, right? Good, thank you for confirming. Okay, let's do one more, okay? The last one. The last one is going to be like this. Persons 2 at position 2 is assigned to persons 1 at position 0, like that, okay? So now persons 2 at position 2 is assigned to position 0 over here, right? So that means something like this. That's what happened afterwards. Okay, you can see that used to be, before we run the loop, 0, 1, and 2, they all have the default values of null. But after the loop, they have been properly reassigned as intended. Okay, so now we can answer the questions quite easily. Let's try. Okay, let's go back to the slides and try to see. And, let's do one more things. So now again, we got aliasing, right? So now when we say persons 1 at position 0, that's set age 70. Persons 1 at position 0. Persons 1 over here at position 0, set age to be 70, right? That's the object here. Okay, that's easy. And let's now go to the next one. And then, system out of print line, gym.age. What's gym.age according to the diagram? 0, right? Just as a warm-up, just 0. Has not been set up yet. Sorry. Okay, what about Allen.age? Oh, are you sure? It's 70, right? Yeah, remember we just said it, right? In the previous line. Okay, it's 70. Okay, that's okay. It's okay to be wrong. Okay, 70. What about next one? So persons 2 at index 0.age. Let's try. Persons 2 over here at index 0.age. 0. Good. Pretty good. Now, Let's do one more assignment here. Persons 1, 0 is assigned to Jim. Persons 1, 0 is assigned to Jim. Persons 1, let me see. Persons 1, 0 is over here, right? Is assigned to Jim. So now that means copy Jim's address to here. So that means rather than pointing to here, it is going to point to here. Don't you agree? And next one. Persons 1, 0 that set age to be 75. So now what we're going to set? Jim, thank you, and set it to be 75. So persons 1, 0, which we just reassigned, so now it should be 75. Good. And now when we say system out of print line, Jim.age, 75. Okay, should be no surprise. And then finally, Alan.age. Remember one thing to note, persons 1, 0, before we do this line number 13, it used to point to Alan, used to. But since we do the reassignments, so when we actually do line number 14, 75 was not set to Alan. Okay, notice that. It's a very good insight to see. Okay, when you say Alan.age, it should be 70, remain 70. Finally, persons 2, 0.age, persons 2, 0.age, 0 points to here, 0. Okay? Any questions? You can definitely try the source code I made available to you. You can try to see over here, I would say, try to play with the program by modifying somehow by your own will. Line number 8. Try to change the expression, like how pointers can be moved around. Try yourself and see if you can make sense out of it. Because if I give you something similar, line number 8 would be something I'm mostly interested to see how the pointer should be moved around. Okay? That's really important. And don't ever try to just calculate in your mind. It's not possible. It's not human. Okay? You just got to trace by yourself by drawing diagrams. Any questions about this example here before I move? Okay, I would say that's a challenging one, but it's not so bad. Okay, good. So now we have finished this example already. So now I would like to show you something small but new, which you maybe haven't seen before in 2022. This something very convenient, which we will use when we talk about exceptions. So maybe let me just talk about it just right now. It's something called anonymous objects. Anonymous object simply means you have an object, but you have no name for that. So that means an object simply have an address, but the address is not stored in some variable, simply no. Okay, that's basically what it means literally. Now let me try to give you some idea. Again, we can get some insight about the phenomenon for reference type by just looking at the primitive type. Let's have a look. Can somebody try to explain to me, compare with these two fragments of code, we simply calculate the square of the input, right? Can you tell me what's really the difference over here? They are both correct. They do the same thing. From any user's point of view, you cannot see any difference. It's mainly about line number 2 and 3 for the two fragments. Can somebody try to explain to me what's really the difference here?
The second part returns an anonymous object.
Well, okay, you say anonymous object, right? But you remember X, it's double. There's no object here.
Oh.
Okay, but that's a good try. Yes.
For the second one, it's not being...
Maybe it's left and right. That'll be better.
Right, it's not being stored in a variable. But for the left one, it's being...
Okay, very good. That's exactly correct. So for the left hand, let's talk about the right-hand side. For the right-hand side here, it's for our convenience because we know the thing we want to calculate is extremely simple. We don't have to store the computation result in some intermediate variable and then return it. We just return the value directly, right? That's what right-hand side is doing. You just return x multiplied by x. On the other hand, the advantage for the left-hand side, what we're doing is we say that let's make a temporary, let's make an intermediate variable square, SQR, square, which will store whatever result it is for x times x. And then the advantage is, let's say if you have a more complicated program. In that case, you may not want to just return square. You may want to return, let's say, a square root. In which case, between line number 2 and 3, you can refer to just SQR. you don't have to refer to x times x every time. So you can save some computational result, some computational resources, right? So basically, left-hand side, you do have a name reference for the computation result, the x times x. On the right-hand side, you don't. Okay, that's basically the difference, crucial difference. So now, let's now try to understand these two fragments. Now, the left-hand side makes sense to you. It's very easy. Let's try to understand the left-hand side before we see the right-hand side. For the left-hand side here, line number 2, we are trying to create a person object. Let's be more precise. The right-hand side of line number 2, we are creating a new object in the memory and then store its address into some intermediate variable called p. That's why we can refer to p in line number 3. But we can definitely do much more if we want to, right? Because let's say between line 2 and line 3, we can even say p.getWeights or p.getBMI. You can just refer to that intermediate variable which stores the address. On the other hand, on the right-hand side, this is something new for you. Okay, I'll try to explain to you the syntax-wise, but let's just try to understand its meaning. Right-hand side achieves exactly the same thing. Line number 2 on the right-hand side is simply return the address of some newly created objects. However, that newly created object's address is not stored anywhere. It is not stored. You just return that right away. There's no intermediate point to see it. Okay? That's the crucial difference. But now let me try to explain the syntax to you. Okay? So now let me just make a new page on my iPad and then I'll switch. Okay? Okay, over here. So now, basically, thinking this way. Let's try to understand our typical object assignments in a different way, from a different angle. Let me just put it here again. Person P is assigned to new person. Let's say Jim. Like that. Okay? We understand the meaning for this very well under the hood, but now I would like to say, syntactically also makes sense. We can just use this part over here. Just this part. Because this part over here, you can think about, oh, maybe I should choose a different color. Over here, this part here can be ignored. So this part here is just about store address of anonymous objects over here. So if you only look at this expression alone, the object has no name. It's just somewhere in the memory. It just has no name for you to refer to. But if you really want to have a name for that, you better do the orange part. But there will be scenarios where you just want to refer to the red part. Okay? So this part is the anonymous objects. Okay, this part here. Okay? That's how you understand it in syntax. There's no new syntax for you to learn. You just have to know which part to include. Right? Okay, let's see some example. Okay. Okay, exactly that. Okay, so let's see some example. So there are certain typical usages for anonymous objects. Let's just see some of them. Okay, it can be used as the right-hand side for the assignment. So that's why I mentioned assignment sources, or you can use as argument values, which means when you try to call a method and the method is expecting some objects, you can pass anonymous object. It's also possible. Let's see example. They will make sense to you. Let's say we have this. I'm actually going to review this pattern today with you quickly by using a more difficult example. But for now, you should be very familiar with this if you took 1022 with me, but you have not, that's okay. Basically, we have a class member here. We have an array of order. And then we have some counter to tell us where we are by adding the order, right? And then let's say we don't worry about the constructor for now. You just omit it. So now let's see this. We have an add order class, add order method here, which will take some order objects and then we simply can do the assignment like this, right? Assign that to the current position and increment the counter. Nothing new. Now, what I would like to do is to do this one here to see if that makes sense to you. Okay, we have done also this, something like this before. Okay, so you can see over here, add order is going to take the information necessary for you to make a new order objects. What you could have done instead of one-line implementation was, you could have just simply said, I'm going to say order O is assigned to new order NPQ. I'm creating some variable, some order objects, and make a name for that. And then pass that name. So you can see that. Let's compare. So they are completely equivalent. Can we simply just compare over here? You know what? Let me, okay, stare at these two versions there. I will try to make it clear to you. I'll put it on the iPad. So we have name, price, and quantity. Okay. Let me show you the different versions you can write. Okay, like over here. Let's talk about the version where you don't use any anonymous objects. So you can simply say order O is assigned to new order and then N, P, and Q. And then you can say orders over here at position, number of orders is assigned to O, and of course you can increment the counter. That's the version possibly learned before, okay, with no anonymous objects. But now we can make version 2. Version 2, we can combine these two lines together. We can do that, okay? Basically, we're saying that we are reusing the name for O for just once. Why don't we just pass that name? Why don't we just pass that address directly? So basically, O is going to store the address of this anyway, so why don't we simply just move this over here? That's kind of the idea. So the second version there is going to be orders at position NOO is simply assigned to new order NPQ. That's second version, the green one. We can combine these two blue lines into one line. Okay? It can be further simplified. Okay? You can see that over here, the green version there, we are doing orders at position NOO is assigned to something and NOO plus. And this pattern is somehow repetitive because remember in the previous, let's look at the slide here. Remember we already got a method like this, right? It got exactly the same pattern. So what we could have done is to say, why don't we simply pass that anonymous objects as the argument value for this as a helper method? Okay, let's see how that can be done. Okay, let me now just make a different version for you. So now all these can be done. Another version over here. What you could have said, let me make it a little bit slower for you, okay? What you could have said was order O is assigned to new order. And then we got NPQ. Okay, the pink one is the version number 3. And then you can say add order, and we are calling this version over here. We're just calling this version here. Okay, so it's expecting some object over here, O. Okay, that's version number 3. Make sense? Version number 3? And for version number 3, there's no anonymous object, version number 3. So now, finally, how can we move to the final version, version number 4? Similar arguments. Over here, you can see that we are passing this variable over here as the argument value, and it is storing the address of this new object here. And we are reusing the name O for only once. So why not just pass the address directly? So basically, we're going to pass this directly to here. Okay, here comes the final version. I'll write it down here. Version number 4. We're going to say add order, and then new order, and then NPQ. That's the final version. Okay, so you should really try to understand version number 1, which is blue, and then version number 2, which is green, and version number 3 and 4. Okay, we got 4 versions. All of them work. Some of them use anonymous objects, some of them do not. Okay, so you can feel free to choose whichever style you like, but it's quite convenient.
So this increase the compile time or not?
No, for compile time, runtime, it doesn't really matter so much, I can say. These are trivial. I would say this is which one should you use? I would say it's more like a personal preference. whichever way that's going to make your code more comprehensible, use it. But I would say typically, okay, here's the principle. Okay, let me write the principle for you. But it may not apply always, but just you can think about it to see if that makes convinces you. I'll put the principle here. Apparently, version 4 is the neatest one, right? It's very compact, just one line. Version number 1, even though it's 3 lines, but I would say if that makes sense to you, that's fine, right? So here's the principle. If you only have to use the reference variable once. For example, you can see that O over here is used only once. Use anonymous objects. Otherwise, if you have to refer to the same object for more than one time, you better use the name reference here. Okay? I have a good example for you. How about that? Okay, so far so good. Let's clarify this. This is really important. Okay, let me have an example for you. Now I'm going to actually make 2 versions of code for you. And now what I would like you to do is to think about, number 1, do they generate the same output? And number 2, do they really mean the same thing? Okay, so these are the 2 questions. Okay, I'm going to write it down. Okay, so left-hand side, let's assume we got person class, okay? Let's say person, I'll say P1 is assigned to new person Jin 80 and let's say 1.7. Okay. And then I'll say print standing for system.out.print line. P1 dot get BMI print P1 dot get BMI. Okay, that's version number 1. Now, version number 2, I'm going to write in a different color. Print new person Jim 80 1.7. Okay, make sure I bracket well. Dot get BMI. I should be able to just copy this. Okay, now question number 1. You don't have to tell me the exact numbers. Question number 1. Let's call this L, left, R for right. L and R produce the same console output or not? Question 1. Yes, very good. We got consensus. L and R have the same visualization, how about that, or meaning, have the same meaning, which means can they be visualized to be the same object structure? Okay, it's very important. Question 2 is definitely crucial. False, I agree, but can somebody try to explain to me? Anyone at the back would like to try? You know, I should give you an opportunity. Yeah, go ahead. Which one, left or right?
The right one.
The right, okay, the right-hand side, yes.
Whereas on the left-hand side, you're pointing to the same one.
So basically, you're trying to say on the left-hand side, we get the same result because we're trying to get a BMI of the same person. That's why we got the same BMI. On the right-hand side, We are basically trying to get a BMI from two different persons who just happen to be of the same name, of the same weights, of the same height. So it's different meaning, okay? Everybody follow? Okay, just to bother you a little bit more with diagram. How would you draw the diagram for that? For number one, basically P1 is pointing to a person object over here. So we have name, weights, and heights. And then it's going to be Jim 80, 1.7. And for this line here, P1, you talk about this object. P1, the same objects. Okay, right-hand side. To evaluate the print statement here, we have to make sure we know what the context object is. So we are creating this on the fly. Okay, we're just creating right away. Okay, so that means for that one, it has no name, just address, no name. Over here, and then we're creating a person over here, and then name, weight, and height, Jim, 80, and 1.7, and then get a BMI for this object. Okay? What about the right hand? What about the second one? The second one, I can simply say the same object here, but different objects. They got different memory location and got different addresses. They just happen to have the same attribute values. And now for the second one over here, I'm going to say get BMI for this object here. Okay? Even though I got the same output, but for different reason. Okay? Questions? Good question. In this case, let's say, okay, very good question. Let me rephrase it. Okay, I think this will be a little bit more complete to ask. It's a good question to follow up. Let's say line number one, line number two. Let's say we still got so many lines in the same method or some tester. Is it possible to refer to this object anymore? No. You only use it once, and that's it. And here as well. Questions?
Well, just saying, like, as soon as you don't have any references
Yeah.
to the objects,
Yeah.
they get deleted.
Oh, good. Garbage collection.
Yeah.
Basically, what Jordan said was, okay, just for your knowledge, in Java, since we try to draw memory diagrams always, I want to show you something here. So you can see that over here, for these two objects over here, you can see there's no pointer pointing to them, right? So that means the Java runtime is going to somehow do some periodic check to see if there's any objects we call it often objects. In that case, they're going to be garbage collected. If you program in C, you will have to do such freeing the memory management yourself. But in Java, you don't have to. Do you think that's really advantage or disadvantage? It's debatable. Because in C, which we will learn in 2031, maybe some of you are taking it, you can actually you can do some arithmetic on the addresses. But in Java, you cannot. But I personally don't like to do arithmetic on the addresses. It's quite error prone. So Java is nice. Okay, yes? Yeah, the two objects, both of them, yeah. P1. Mm-hmm. Oh, good question. So let me try, okay, everything's about context. Let me try to explain your question a little bit more, okay? And then I think that'll be good. Okay, so now, of course, this may not be so much like a review. We're just talking about new topics, right? Just programming in general. How about this? Can I just put this block of code into a method called M1? Okay, imagine that this is the M1, okay? So let's say over here, let me just do it again. M1. Okay, if I talk about the rest of method M1, you definitely can use P1, right? It's within the scope. However, what you were basically asking was, let's say over here, let me just say over here, let's say I create an object O of the particular type and say O.M1. And following that, can I refer to P1 anymore? The answer is no, because P1 is only local to this particular method, which only exists over here. As soon as that method terminates, whatever local variable you declare over there are gone, disappear, okay? Unless P1 is actually an attribute, unless that's the case, but it's a different issue. Okay, guys, try to follow these issues. I think they're quite handy, right? Doesn't matter what programming language you program. So as soon as you finish your block of code, whatever local variable whose scope is limited to that block will go away. They will disappear. You cannot refer them outside the box. Okay. Questions? Are we okay? Okay, good. What I would like to do is do one more example. Oh, actually, I think one more example for anonymous object, but I think this one you have seen already. Let's say we have a member tester here, and we have a member here, M, and we have some name objects O, and we can also do that, right? It's argument value. So now this should be quite straightforward to you what it really means. Apparently, you can see that for the rest of the main method here, I cannot refer to the highlighted object anymore because that one there, its address is not stored anywhere in the program, right? More precisely, let's say we still have some more code to be written for the main method. We can still refer to O over here, but we cannot refer to this particular object not anymore because that's anonymous. It's gone. Okay. Okay, any questions before I move on to the last example? Okay, good. Okay, let me just summarize about types. So type is a very important notion. Remember back in the first year, if you took it with me, I emphasized that your program must compile, right? To really have your program compile, you have to make sure you satisfy two things. First of all, at least the syntax must be correct, right? You cannot miss a semicolon, right? That's a syntax issue. And the second issue is really more like a deeper issue. That's about type correctness. So basically, you cannot assign an integer to a string. You cannot really assign a person address to a bank account address, right? So these are really like how you can manipulate the values in a consistent way. That's about types, okay? About runtime values. So in Java, we got two types. Primitive types, we got integer, we got floating point, we got character, right? So I believe lab number 1, part 1, you're trying to practice these, right? So these are just over there for your reference. And also we got Boolean, okay? And reference type. So what is reference type? How many reference types are there? Endless. What do you mean endless? Can you really define what are the possible reference types are there? What are the possible ones? Basically, well, you can see that for the primitive type, that's basically all I enumerate over here explicitly. That's it, right? But for reference type, basically every time when you open your Eclipse and type class something, that something can be used as a type. Every class name is a type name, basically, because every class can be instantiated into various objects at the runtime, so they are considered as a type. When I say person, P must be instantiated according to how the person class is defined, and similarly for bank account, for any other classes. So for reference type, it's simply unbounded. So many possible reference type. I'll just give you some example. And in the Java convention there, you can see that for the primitive type, it's basically just all lower cases, okay? But for class name, it has to be capitalized. That's why usually the common confusion is you might think string is a primitive type. No, it's not. It's a reference type. Okay. And also you got person here. Also you got point, things like that, or scanner. Right. Just some example. Everything that you can use to name a class can be a type. Okay. Yeah. Good question. Okay, it's I will mention that briefly here. It's a little bit subtle, but it might be useful to know. Basically, what you're talking about is, okay, here, integer, no question about it, is a primitive type. There is another class called integer. Okay, that one, it does exist. It's a reference type, which means you can do things like this. Let me show you one example. You can try, okay? I'll just show you an example here. You can say integer I is assigned to 3. Integer j is assigned to 3. Okay? And then I can say something like this. Integer, which is a class, which means we can create objects from there. I would say I objects, okay? It's assigned to new integer, and its constructor can simply take some integer value. I'll say I. It's called a wrapper class, basically. I'm going to visualize this to you in a moment. And then we can also say integer j objects is new integer j. Okay, so these are the two lines of code I'd like to have a look. Up to now, from the two lines, how many integer, capitalized integer objects have we created? How many? Two. You just see two new keywords, right? Let's visualize that over here. So you have IO points to integer. And how does the object structure look like? Conceptually, you can think of it in this way. They simply have something called integer value, okay? And then you simply wrap whatever you just stored. In this case, I is simply 3, so you put 3 here. It's like a wrapper. You wrap something that's primitive, okay? And another one would be j objects, which is pointing to another integer over here. Integer value, and then it's going to be j, which is 3. Same. So now here comes the interesting part. Let's do some comparison. And, oh, it might be a nice review I forgot to mention, right? So now what about this? If I say IO, sorry, equals JO.
No.
Yes, no, yes, no. No, why not? You compare references, right? Exactly. So they are different references, so that'll be false. I agree. Okay, good. On the other hand, if you say I equals J, true. Just simply because I and J are primitive, IO and JO, they have reference type, so you compare addresses only. Let me do a little bit preview for what we're going to cover a little bit later in the course. If you say IO dot equals, because they are reference type, so here's one thing you can just remember for now. Every reference type, you can call equals method on that. And we're going to talk about how you can define the equals method, which is way more complicated than you might think. Okay, but we'll do that later. You can say io.equals jo. A little bit like when you say some string dot equals another string, right? Compare the contents. In this case, true. Okay, but you can play with the wrapper class. Okay, it's not very hard. It's just some subtle details you got to pick up, in Java. Okay. But I think it's a good question there. I just want to tell you that eventually we'll talk about equals method. Really important. How would you customize the equality between two persons? How would you customize the equality between two shops or two array container? Things like that. So that's something you can definitely customize as a programmer. That's something we'll do. Okay, good. Okay, so now you know what I will do over here? I do want to go over this example here. Basically, the Java data type, of course, primitive value, you also got default values here. For reference type, the default value is always null. Okay, so be careful. The most common source of error is like this. Okay, how about this? The most common source of error is like this. So in general, whenever you have some object O, which stores the address of some other objects, dot some method M. For you as a disciplined programmer, whenever you write something dot something, what can be the possible error you might have at the runtime? Null pointer exception, right? Over here, like here, the O. Null pointer exception if O stores null. If O stores null. Okay, that's one thing. Okay, since I mentioned that, the second most common error of sorts is you have an array, you try to index into it, and you say I. What can be the possible error here? You know what, this is interesting. You might think index out of bound exception, that's correct. However, even before that happens, it is also possible to have a null pointer exception, right? Think about how Java is going to do this, okay? That's why I want to talk about this. So the way Java is going to evaluate this expression over here, first of all, it's going to look up to see where A is in the memory. So it might just get a null pointer exception right away. Correct. If A points to nowhere, or simply stores null, that means points to no valid location in the memory, that means you don't even have to talk about indexing. Right? If this points nowhere, logically speaking, right, you should really report the error that should come first. And this is something that Java checks first. Yes?
This is like a short circuit we talked about?
Not really sure. You know what? It's good. Let me go back to the short circuit. I like that. Okay, I'll come back here. Okay. I don't want to go too much detail into short circuit. I can talk about for 30 minutes with non-stop, but I will talk about this in just one moment. Okay, that's the first source of error. And the second one is, let's say A is not null. In that case, we have to worry about I. I cannot be either too large or too small. If either case happens, index out of bound exception. Index out of bound exception. Okay, let me just talk about short circuit very quickly. Okay. Now, let's say I do want to put this expression here in my code. What would be the safest way to put it? Right? If I want to, let's say I want to evaluate an expression like this. I want to see, let's say A stores integer. If AI is larger than 0, I just want to check to see if that's positive or not, let's say. So now it's going to return a Boolean, true or false, but now I don't want anything to crash. One way to protect this is by checking to see A is not null. Also, I is neither too large or too small, and then AI is larger than 0. Okay, let me put it down. And I will give you different options since we talk about this. Let me give you different options here. A equals null. Let me put it here. AI larger than 0 and I 0 less than or equal to I and I less than A dot length You know what? This is the best way to put it. Now I got it. And then we also got A not equal to null. Okay? Can I just name them? Can we say this is number 1, this is number 2, this is number 3? Okay? Now, let's consider the first version. If I got 3 and 2 and 1. I'll just give you two versions. You can think about other combinations. Versus if I got 2 and 3, 2 and 1 and 3. Okay, question 1, question 2. Both questions are, of course, think about other combinations as well, right? You just apply the same reasoning. I'll just talk about two of them just for flavor. For number 1, can things go wrong at the runtime? Remember, we talked about two sources of error. A can be null, and I can be either too large or too small, right? So these are the two kinds of errors. Can the first version there, 3, 2, 1, can it go wrong? No, right? Okay, let's, again, short circuit, you can refer to my, you know what, if you really want to find a detailed discussion, go to the review lecture back in end of August. Go there. I remember I spent quite a big chunk of time talking about it. refer to it if you're interested, okay, for 1022. Okay. So now, over here, so now let's say this, we will do 3, 2, and 1. Okay, let's say we have the worst case. Let's say A is actually null, right? And then, if A is simply just equal to null, what's going to happen here? Well, that means 3 over here is going to evaluate to false. And the short circuit for conjunction simply means as soon as you find something that's already false, the overall result will be false anyway. You don't have to continue to evaluate it, right? So we simply say false. So it wouldn't crash. So now to test your understanding, is Q2 okay ever? Always? Maybe sometimes it is okay. Sometimes. How can it go wrong? Okay, somebody want to try before I point to you? Anybody want to try for question 2? Anyone? Nobody? Okay. You want to try? Yes, number 2, question 2. Yeah, how can it go wrong?
When testing 1 and A is actually equals to null.
Say it again, I don't quite catch you.
When testing the second part of the, testing 1 and A actually equals to null.
Good, good. So somehow, actually, you know what? Not even. Actually, 2 is actually even worse than you might think. Remember number 2 over here, in order to evaluate this, you got to get A the length, don't you? Right? So that means for number 2 over here, when you evaluate this, null pointer exception. When evaluating A the length, okay? If A is null, happens to be, okay? Yeah, so short circuit is also quite an important topic for you to understand. If you still struggle with that, maybe talk to me during my office hours. I'll try to see how we can get it sorted. Okay, good. I tell you what my plan was. My original plan was to go over one more example, but I would like to delay that a little bit. Maybe later on we'll talk about something called hashing for one of the methods for Java. Maybe I can introduce that topic a little bit later, okay? But I'm gonna do that. I'll find some time to do it. But what I would like to go for now, you should really be able to just review all the lecture notes, everything we have covered. This is the only example which I would like to go over with you with some visualization. This one here. Try to see if you can understand it. It might be covered in lab test 1 some way. But just go over that, okay? And for this particular one, I want to point to you, there is a PDF notes I wrote over there. You can see that at the end of 3.2.1, there's a link over here. If you click on that, there's a PDF document for you to go over. It talks about how this should be visualized. I will try to find some time to go do that together with you, maybe halfway through the semester. But for now, let's move on to some new topic, okay? At least I want to give you some motivation about why we need exceptions in Java, okay? That's what I would like to do. Okay, so now we are done with all the review topics for classes and objects. But if you still got any concern, speak to me during the lab session or office hour. Okay, so now let's talk about exceptions. Okay, we are going to use the exceptions in this course in a very specific way. Okay, but before that, I would like to just give you, again, whenever you do things, don't simply just accept them. You want to know why we're doing them. It's more important. So I would like to just talk about exceptions here. Maybe I got about 20 minutes or so for today. At least I want to give you some motivation why we want to do exceptions. And then as soon as we start a lecture next week, I'm going to tell you, technically speaking, how can you do exception. There's certain things you have to memorize, I'm afraid. Some small details. I will guide you through it. Okay? But before that, let's just do that. I will show you some slides. I'll show you some source code. Basically, this is the roadmap. I'm going to give you 2 examples there. And for each example, first of all, I'm going to show you how we do error handling back in the 1022 way, at least in my class. How we can simply print out some error message to the console, for example. Or how you can simply display the error message on the tablets, right? That's it. That's one way. The second way is how you can do it with exceptions. Okay, we're going to compare how things can work together. Okay, today we're just going to talk about the first version without the exceptions. Okay, let's first of all let me clarify some terminology here. I think since you're in the second year, it's really good. Things will get more and more complicated, right? When you call methods, you don't necessarily just have a very simple scenario. You may have a chain of method calls. So that's something we're going to run into. Okay, but let me just explain to you by using a very small fragment of code. Okay, let me just introduce the notation to you. Over here. Okay, you know what? Let me just swap their position so that'd be easier for me to switch. Good. Caller versus callee. Okay. If you haven't known this, that's okay. So let's learn it now. Okay, caller and callee. Caller means some method which is going to call some other method. Callee means some method that is being called by some other method. Sounds different, right? Or it sounds the same? Well, let's see. Let's say this. I would like you to, let's say hypothetically, we have a class called C1, and then we have a method called M1 inside C1, and then inside M1, we are trying to create another object of type C2. And then we are trying to use O as a context object there and call another method M2. Now tell me something, from what we have seen so far, where should method M2 be defined? Where? Should M2 be defined in C1 or C2? C2, right? Because you can see the context object here, O, is of type C2. If M2 was actually declared in C1, that means this code would not even compile. But let's assume it compiles. Okay, following the arguments over here? Okay, good. It's a simple example here. Let me introduce the notion for you. So every time when you have a line like this, typical over here, let me use a highlighter here. Every time when you have something like this, like a method call, okay? Every method call suggests certain caller-callee relationship. But you have to see who the caller is and who the callee is. Okay? So now callee may be a little bit more, maybe a little bit easy. Well, actually, both are easy. How about caller? Caller basically just to tell under what class was this method call being made? C1. And more specifically, it's under M1. So we can say that over here, C1 and M1 combined together, that's the caller. That's where we initiate the caller. Okay, we're trying to call this particular method here. What about callee? Callee is someone who's being used, right? So now over here we can see M2 is being used. And we know that M2 should be defined in C2. Okay, so now that means over here, C2 M2, this tells us it's callee. Okay? Caller and callee. Any question about this? And before you ask your question there, let me give you another pair of names which people also use, and maybe that's a little bit more relevant to your real life. Client versus supplier. How about this? Let me just tell you what client and supplier mean, and you can tell me which one should be which. And client supplier is also the next topic I'm going to cover, a little bit about decide by contracts. So we'll get there. So maybe a little bit preview. Client versus supplier. Supplier is someone who provides the service. Client is someone who uses the service. Based on this, do you think C1 and 1 being the caller, is it a client or supplier? Supplier, client? In this case, is C1 and M1 being used for their service? They use service, right? They're not being used. Okay? So now over here, so caller over here, at the same time, clients. Using M2 specifically. Okay, and you should now see over here, C2 M2, in this particular case, it is the supplier. Because when you call O.M2, you're calling the method for certain effects, right? You're using the surface there. The client supplier, caller, callee. You should know both pairs. Okay, client supplier, caller, callee. Okay? Try to review this concept because we'll refer to them quite often in the course. So now another question for you. Can a method be a caller and a callee at the same time? Yes, right? Can you imagine can we expand the current example just a little bit and try to make it happen? I will try for you, and you tell me if you're convinced. Okay? Over here, we talk about, first of all, you can see CM2 over here is the callee. Can we also make C2M2 a caller? It's possible. Okay? Let's expand the context over here. Let's say we also, let me use different color here. Let's say we got, let me expand it, say class C2, right? Let's just complete the missing puzzle here. And under C2, we have void and M2. And then under M2, let's say we have another class called C3. Okay, I just made it up. Okay, C3, and then we'll say object O is assigned to new C3. And then we'll say O dot M3. Okay, so now you can see a new pair of client supplier. Right? So now over here you can see that C2M2, which used to be a callee in this context over here, is now becoming a caller. Calling what? Well, calling this one here, right? And that is callee. And of course, the story can go on depending on how complicated your classes are. Okay? The caller callee is not really like an absolute term. It's relative. Okay? Good. Good. Now let's see at least one motivating example. Okay? And then I'm going to run some Eclipse for you, and then we can go a little bit more quickly, maybe next week. Okay, now let's have a look at this. Why do we need exceptions? Can we consider this very primitive class, circle? Let's say we have a circle class, and we have an attribute radius, and we have a constructor, which simply just default the value to be 0. And then we have set radius of the circle to be some double value r. And then, now let's do a little bit error handling. Okay? We say if r happens to be negative, then we'll print out something to the console. Invalid radius. Okay? Otherwise, we'll say radius is assigned to r, right? Basically, if it is invalid, print some error message and don't do anything. Otherwise, set r to be the radius. Okay? Easy class. And then we also get area over here. Okay? So far, so good. Now, do you see any potential problem over here? Let's say any clients who wants to use the service of the circle. Is there any issue there? I can tell you that somehow line number 5 is doing something useful, but it's not strong enough. Okay, that's something I can tell you. But let me see. I believe I got a code here on iPad. Let me just see that. Okay, let's have a look. Okay, let's consider this example in detail. Okay, so now again, let's say we have the circle class we already considered. So circle class over here. Let's consider another circle calculator. Okay, and apparently circle calculator. Oh, now just based on the usage over here, who is the caller? Who's the callee? Set radius is the callee, right? It's being called. And circle calculator is a caller. Okay, just clarify. Again, callee is the supplier and caller is the client. Okay. Now, I want you to execute in your mind rather than using Eclipse. I'll prove it to you in Eclipse anyway. Let's say this. We try to execute the main method over here as Java application. These 4 lines of code. Is there anything that's going to be funny going to happen in the console? Before you do that, yeah. One moment. Yeah, let's think about it for just a few moments, okay? And then tell me exactly, how about this? Tell me exactly what the outputs are, and then why do you think it's wrong? First of all, there's no null pointer exception, no index out of bound exception, okay? Nothing like that, okay? It's more about a logical thing. Anyone? Okay, why don't you try?
When you put, like, you'll get the invalid radius message, but then when you go to double get area, you're still going to calculate it.
Aha, exactly, that's exactly correct. Okay, let me try to put more details to your answer. That's exactly correct. Okay, now, okay, what I would like you to show, to see over here is, let me use color here. Okay, first of all, when we are in this line, C dot set radius minus 10, we are going to go into this branch to say invalid radius. Invalid. In some way, the client who is the circle calculator is already making a fatal mistake because it's trying to get a circle of radius minus 10. In principle, if you have made a fatal mistake like this, you should be stopped right away. Your flow of control should not continue as normal. However, in this case, printing out something to the console does not prevent the caller to stop, which means as soon as we are at the end of this line over here, we can still continue. There's nothing that will force the client to stop. Okay, that means we'll still go into this line over here, which means we are trying to calculate the area for a minus 10 radius circle. That doesn't make any logical sense, does it? Right?
It is minus 10 or actually 0 because no value is set.
Oh yeah, exactly. Yeah, I'm just trying to say you're trying to set it to be minus 10, but what your program does, you could set it to minus 10, or you can set it to 0. In this case, yes, what you will do is it's going to set it to 0. But from the client's point of view, from the caller's point of view, it doesn't know what you set it to, right? Good. Okay, so now we're going to do that, and then finally, you can see that we are still going to print out this line. Area over here, because over here we didn't set it to R, so it will remain to be 0, right? You would say 0. It's going to tell you invalid radius, and then the area is 0. If you look at this output over here, imagine if the client sees this, they will be puzzled. What do you mean? Radius invalid, but somehow you get an area 0, right? What should have happened was, as soon as this error over here happened over here, this line over here should have been interrupted. Should have been interrupted. Okay, that's the thing. Okay, okay, we still have 5 minutes. Okay, let me just use a little bit more time. Okay, any question about this example here? Okay, we're okay, right? Let's see something a little bit more complicated. Oops, something a little bit more complicated. What I will do is I will go in details for these codes with you next week, but let me just show you the code right away. At least you get a big picture, okay? All right. Okay, let's see, we have 3 classes over here. Let's say we have an account class. We have account, and then we have ID, we have balance over here. And then we have a deposit, okay? Deposit, we simply say, if the amount you're trying to deposit is negative, then I will print out some error for you, okay? And then, otherwise, I will try to increment your balance, okay? That's deposit. For withdrawal, it's going to be done in a similar way. So now, by the way, what's vertical bar, vertical bar? Or, right? Good, okay? I'm saying that I'm going to print out an error if either the amount is negative or the balance is a little bit, if the amount is too big. Because subtracting the amount will give you negative balance, right? Okay, that's about withdrawal. And that's about the account class, okay? That's the first class. Can we just introduce a second class very quickly? So now we have a bank, and a bank simply have an array of accounts. Okay? And then we say we want to withdraw from a particular client with the ID some amount. Apparently, you can see that in order to implement this method, we can definitely call the withdraw method from the account class as a helper method. Right? That's what we'll do. Let's see over here. So we're going to find out where that particular account is. If the ID matches, then we'll simply say, now let's make a call. So accounts I, which will find out the particular account objects, and that withdraw A. Okay, now line number 7. What can be wrong over here? Line number 7. Similar reasoning as before, like a radius example. Okay, line number 7. I have a question for you. What if, let's say at this level here, I say I want to withdraw from ID 5 minus a million. Apparently it's a fatal mistake, right? Whoever is initiating this call, they should be stopped and program should crash, well, somehow crash. However, in line number 7, when you pass minus a million, apparently it is going to execute this withdraw method here with minus a million, and then according to the original code, minus a million is going to satisfy this notation here, this condition here, right? And then it's going to print out the error, and that's it. So that means only a message is printed out to the clients, to the console, but it doesn't really stop them. They can still go on with their code. Okay, pretty much like what we said before. Okay, one more mention, and then we are done. Okay, I will still review this from a more higher view next week, and then we'll do exceptions. Okay, one more class, bank application. For bank application, we have a main method here, and then again, we have scanner, and then we have bank over here, and add account, and then we'll simply say bank.withdraw from 23 and then A. So basically, bank application is going to call the withdraw from the bank class, and the bank class is going to call the withdraw method from the account class, right? So we got a chain of method calls over here. You can see that, right? And we can see that if we pass minus a million in line number 7 for A, eventually it will go to the withdraw method for the account class and print out the error message. But nothing is going to stop line number 7 over here to crash. Nothing is going to do that. Okay, it's an issue there. Okay, how about I stop here a little bit earlier today? Okay, so review 2-dimensional array, you'll be useful. Okay.